Hello, my name is Bill Henning. Thank you for your interest in GeoLearn and for your interest in this part 1 of a series on real-time global navigation satellite system positioning. Let me just take a moment and explain to you what it can offer you. I've been upwards of 46 years in the land surveying field, with in part in private industry as well as public. And 20 of those have been involved with manufacturers' real-time positioning systems. I've also been fortunate to have worked with colleagues at NOAA's National Geodetic Survey, the brilliant folks there. And I was involved with the authoring of a document on real-time positioning, as well as a document on real-time networks. Spearheaded a group of individuals working on that draft document. So in this session, we'll be talking about a number of things, but we'll be dealing with what's inside the black box of your rover and how does it work. We trust it a lot, don't we? But things have changed rapidly. It's getting better and better. But it's worth our while to understand what's happening a little bit in there. Now, we're not going to know everything because the manufacturers are very protective about their proprietary algorithms and their systems. But we can make some general comments about how things are working. So in this session, we'll be talking about the near future of our monuments, not in the ground, but in space. We'll also be talking about a thing called ambiguity resolution. What is that, and why is it important to real-time positioning? We'll be talking about using the guidelines a little bit, and we'll be expanding on that in the other sessions to follow this one in part 2, 3, and 4, at least. Then we'll be dealing with something called differencing. What is that, and why is it a good thing? Also, we'll be talking about real-time versus static positioning. How good is it? Is it better? Is it as good? We'll try to find out. And then what's happening now with autonomous point positioning? We never used to care about that, especially for surveyors and engineers, but maybe we'll take a quick look at why it's becoming important and why it's getting better and better. So let's begin. Real-time positioning wouldn't have been possible too long ago because we're dealing with atomic clocks in the satellites. We're dealing with communication that has to be done in seconds between a rover and a base, between a network and a rover. Communication is the king of real-time positioning. The hardware, the software have continually improved over the years. I started in the mid-90s, and at that point it was kind of clunky. It worked fine, and we used spread spectrum radios, line of sight. But now there's many more constellations becoming available, many more frequencies in the GPS constellation. It all boils down to a system that becomes more robust day by day, more advanced day by day, and enables us to provide engineering and survey solutions within a few seconds.